Welcome out there this afternoon. It's a good old Friday afternoon. You know what that means? It means it's time for specialized segments here on TNLearn Mathline. I'm your host, Ernie Roberts, for today's show. And we're going to do a little, like I said, in-depth discussion, working problems of a topic. So you don't get to call in today, that's okay. You can still send us Facebook, you can still send us emails, all those good things. But we're just not going to be able to respond to them live on the show today like we do many other days during the week. That's our Monday through Thursday regime, all right? But if you will, sit back, relax, get you some pencil, get some paper. I don't think you're going to need a calculator today, okay? Just thinking, just saying, all right? And we'll go with it. Let's learn some math, all right? Let's see what we got going on today, guys. What's my topic that we're going to look at today? Things can be so easy. You like that when I say on a Friday afternoon around 5 o'clock or 6 o'clock, depending on which time zone you're in, you're going to say, I want it to be easy. So what we're going to do today is going to look at inequalities. Inequalities, solving some basic ones, how easy they can be. One step, basically one-step situations, all right? Which means the problems are little. But next week and the weeks to come, we're going to take some of those little problems, add them together to make bigger problems. And you know what? If you can crank out the little things, the big things are also going to be easy. Easy, all right? So let's take a look at this first problem we got going here today and see what we've got. It says, given the inequality, 2 is less than 6. Everybody agree out there? I hope everybody agrees. Yeah, 2 is smaller than 6. So the inequality is correct as stands, all right? So is that all we're going to do, Ernie? Say true or false? No. We're going to play with this a little bit, all right? Let's say I'm going to start with this 2 less than 6 over here, all right? And what I want to do, I want to ask, what happens if we add the same number to both sides? Let's say I add, for example, 3 to both sides here. So we add 3, and we add 3 over here. And what happened was I have increased 2 plus 3 is going to give us 5. And I've got 6 and 3, which is going to give us 9. So I want you to notice something here. I added the same thing to both sides, and 5 the results, and 9 the results we have, the less than still holds, all right? So the inequality did not change. Anytime we add a number to both sides, it's going to work great, all right? It's going to be fine. You say, well, Ernie, what if we subtract? Well, let's try it. Some of you may not be saying that, but hopefully now you're thinking that, all right? So let's do a little subtraction on this. This time, let's subtract. How about 2 from both sides of this inequality, all right? I tell you, sometimes it's hard for me to say the word inequality over and over again, but today that's what we're talking about. So understand, sometimes I get excited and I'll say equality or equation, but these are inequalities we're looking at today, all right? By the way, 2 minus 2, of course, that's going to give us 0. 6 minus 2 is going to give us 4. And you know what? 0 is smaller than 4. So again, the inequality holds here. So what I want you to notice, if you add the same number to both sides or you subtract the same number from both sides of an inequality, nothing happens, nothing changes. You keep, if you start with less than, you keep it. If you start with greater than, you keep that, all right? So let's see what happens if we multiply. What happens if we multiply? How about it? Let's say we've got this 2 less than 6, which we're going to be our base here for a couple of minutes. Let's see what happens if we multiply by 2. So we're going to say 2 times 2. And on the other side, we're going to say 6 times 2. And I already gave you a little hint that it's going to be less than. Well, let's see if that works. I've got 4. I've got 12. And you know what? It's true. So it looks like if I multiply both sides, the inequality still holds. Well, what if I'd multiplied by 0? What if I'd done 0? I wouldn't have a less than anymore. If I multiplied both sides by 0, I would all of a sudden be 0 and 0, which is equals 2. All right, so that's one thing we've got to watch out for. Now, another thing we may want to watch out for is, what about those pesky negatives? All right, let's try that. Let's see what happens if I've got 2 less than 6. And this time I'm going to multiply a negative 2 times 2. And I'm going to say 6 times that negative 2. So in other words, I'm going to multiply both sides by a negative number here. And let's see what happens here. I have negative 4 on the left. And on the right, I've got negative 12. Now the question is, my friends, is negative 4 less than negative 12? And actually the answer is no. It's not less than. We just had a major shift here. Negative 4 is actually greater than negative 12. So what I want you to start noticing here is, now when we add or subtract, life is good. If we multiply by a positive, life is good. inequality stays the same. But when we multiply through by a negative, oh my goodness, the inequality takes a shift, okay? So it goes from less than now to greater than. So dear friends, be ye careful. That's one of the things with inequalities. When we start dealing with adding and subtracting, no problem. But when we start multiplying by negatives, we've got to watch that the inequality will shift. When we start solving equations for x, and I say there said equations, the inequalities, we're going to have to watch out for that shifting, okay? Not only do the signs change, but also there is going to usually be a shifting from less than to greater than or greater than to less than, all right? And again, those are things we need to look out for. Let's do a couple more off this figure just a second. We can bring back, thank you guys. And we've got, let's say we've got 2 less than 6. This time I want to divide both sides by 2. And we saw what it worked for multiplying. Let's see what happens when we divide both sides by 2. I'm going to have a 1 on the left. I'm going to have a 3 on the right. And voila, it didn't change, did it? We still have a less than relationship because 1 is smaller than 3. But let's go over and let's say we divide by negative 2. All right, we start with 2 less than 6 again. And let's divide both sides by negative 2 and see what comes up. When we do that, I get a negative 1. I get a negative 3. And you know what? Negative 1 is greater than negative 3. So there again, we have this shift. So it works not only when we multiply by a negative, but when we divide both sides of an inequality by a negative, the inequality shifts. It changes directions, if you will. It goes from less than to greater than, or sometimes if we start with greater than, it would obviously go to less than, all right? So that's the story. That's where we're going today. So we want to make sure we've got the basic rules. So when we add and subtract, inequality stays intact. We multiply and divide by a positive number, stays intact. When we throw a negative in there, when we're going to multiply or divide, that's when things are going to change, and we've got to say, uh-oh, watch your signs and watch the direction of the inequality. All right, so those are, folks, are very, very important things to worry about. Let's take a look at our next problem here. Got 1 positive and 1 negative, which some people, what do you do that for? Because it's fun. It's fun. So let's start over here. Let's just kind of run through the same thing. I'm just going to put a few of these. I'm not going to run us through everything that, like we did the last one, but I wanted you to see all the possibilities a minute ago. Now, let's suppose I start with this, and let's say I want to add, let's subtract. Why not subtract 4? Because sometimes people think, well, if you got a negative in there, it's going to be different. Well, obviously, by the way, 6 is greater than negative 3. So if we subtract the same amount on both sides, that's going to leave us with 2 on the left-hand side. We're going to have now negative 7, folks, on the right-hand side. And you know what? We're still 9 apart. See, this was a difference of 9 between these. They're still 9 apart from there. So subtracting, the same thing. If we added 4 to both sides, we would still be 9 apart because we just basically moved the numbers. The distance between them is still the same, all right? So the big question is, what happens when we run a positive number? Let's divide. How about let's divide through there? Got 6 greater than negative 3. Let's divide by a positive 3 this time. See what happens. You got a 2 on the left. You got negative 1 on the right. True or false? Well, 2 is greater than negative 1. So again, didn't change, did it? Didn't change. Now, let's go back and take that 6 greater than negative 3, and let's divide by negative 3. Run negative 3 through there and see what happens, all right? We're going to have negative 2 on the left. We're going to have positive 1 on the right. Everybody seeing that? And you know what? Folks, negative 2 is smaller. It is smaller than positive 1. So look what happened. Greater than now has shifted to less than. There was a change in signs. There was also a change in direction of the inequality, all right? So what was greater than has now become less than, and folks, it's true. That's what we got to watch out for. So those are going to be some important rules that we're going to look out for today. We are going to watch out very closely for those things. Now, sometimes people ask, well, Ernie, what happens if we get a 0 involved? Well, let's look at what happens if we get a 0 involved. How about I've got negative 4, and for sure, negative 4 is less than 0. Right there it goes, all right? And if we are going to, let's say, add 3 to both sides, we'll do an easy numbers here. I told you we were going to make it easy today. And boy, is it going to be easy, 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 easy. Oh, so easy. Here we go. Got negative 1 on the left. On the right, I've got 3. And my friends, yes, -1 is still less than 3. You expected that. In fact, I went ahead and wrote it in there because I knew that was going to happen. So that's a good deal. When we add the same number, we know it's not going to change the inequality direction. But let's take a look at the division. Let's say I've got -4 less than 0 to start with. Let's divide by 2. +2, if we will. All right? And when we divide by +2, we're going to have a -2 up here. And by the way, folks, 0 divided by 2 does not give us 2. It gives us 0. If we have nothing and we divide it in half, we still have nothing. All right? So be careful with that. Sometimes we get all excited when we see a 0 and we don't know what to give for an answer. That's what it is. We still have nothing there. And is it a less than situation? It certainly is. -2 is smaller than our 0. So 0 works the same kind of way. Now you say, well, will it work if we run a -2 in there? Well, let's try it. Let's see what happens. We've got -4. We got it less than 0. And we're going to divide by that -2. And what's going to give us? It's going to give me a +2, right? Because a negative divided by negative is a positive. But what happens here? I still have 0. Don't put -2 in there. You've got a 0, all right? So we got a 0. And what's going on this time? Folks, 2 is larger than 0. So that's the story. Again, when we multiply or we divide by a negative number, that's when inequalities shift. No other time. No other time. Just when this situation's happening. Now you say, Ernie, why don't you go through this point? Because when we start working with equations and we've got x's and such, and there can be all sorts of answers coming up, it can get a little confusing to people the first time. But I want you to realize that if it works for just good old solid numbers, it's going to work for our variables. It's going to work for our variables. And those are what we call our properties of inequality, all right? Properties of inequality. We have addition, we have subtraction, we have multiplication and division properties of inequality, but we have to preface those with, are we dividing by a positive or a negative? And of course, you can't divide by 0. Or are you multiplying? If you're multiplying, you can multiply by 0. And you can multiply positive or negative. But remember, it's all about the negatives when things happen. And if you multiply by 0, you're going to go from an inequality to a nice old equals if you multiply both sides by 0, whatever case that might be happening to you. So those, my friends, are where we start. And let's go ahead and let's look at some other sample problems. So what we said today, we're going to do the solve graph and we're going to do quick checks on these. These are one-step inequalities. I promised you they'd be one step. I didn't lie. I didn't lie. It's easy. They're easy, all right? We might throw 1-2 step at the end, but most of the time when I start all these problems out, I get rolling so much into them, I forget and don't get all the way to the end of what I hope to get through with you. But let's see what's going on here. This one says n minus 6 greater than 4, all right? So we're looking for numbers that would plug in for n. Notice I said numbers because there's more than one answer to this thing. There are an infinite number of answers, in fact. You say, wow, that's why we got a number line hanging out here. So let's see what's going to happen. We're going to work it just like we would an equation situation. We want to get n by itself. And I like to get it on the left if it's there. If it's on the right, so be it. We'll move it around to the end. But let's see what happens here. We're going to add 6 to both sides. That looks easy enough. And you're going to have n by itself. And you're going to have 10 here. Now remember what happens when we add something to both sides? We do not switch anything around. We keep the same inequality. We keep greater than. It doesn't go anywhere, all right? So there's a solution. Whoa, my goodness. It says n is greater than 10. Now remember I said numbers? Oh my goodness, they're infinitely many. We're going to have, I'm going to pick a point here, call it 10. It really doesn't matter where I pick it. And I'm going to make it open circle because I'm not including it, right? And we're going to shade it which way? For greater than, we're going to shade for numbers that are to the right. Now you say, Ernie, how do we, and by the way, we make that a little darker there. How do you know that you got the right solution? That's the question. Well, pick a number that's greater than 10. How about 11? It's over here, right? It's in this shaded area. You pick any number you want that's beyond 10. Now, if you pick 10, you're going to get an equals, and that doesn't work, okay? So let's go to 11. How about it? By the way, you could use 10.2. It'll work fine, all right? Anything bigger than 10. But let's look at 11 since it's easier for our arithmetic minds here, and I really don't want to have to go to the calculator. Right, all right? So let's see. If I did 11 minus 6, folks, that gives me 5, and 5 is greater than 4. So any numbers that are bigger than 10 are going to make this true. So this is more of a mental check, All right, we're going to do it mentally. The graph is a number line. You're not having to put this on the coordinate plane, look for x's and y's, all right? This is all about number line. And of course, solving, there you go. One step, you're done, all right? So that's the storyline today, all right? Good stuff, easy, easy, and more easy, all right? That's what I'm wanting to hear from you, all right? Everybody with me? Good. Now, let's look at our next one here. I threw in a less than or equal to. Now, folks, it's still an inequality, all right? It basically means less than or equal to, because I put the little equals mark underneath there. One little line there, one little line segment, I guess we should say. Let's do it. We're going to remove, it's a plus 20, so we remove it by subtracting. And if you will remember with what we did earlier, when we subtract from both sides, we do not violate the inequality. In other words, we keep x by itself here. That's what's the idea, get rid of the 20. And we're going to have a negative 25 because this is just like saying negative 5 plus negative 20. And we're going to keep less than or equal to. That did not change. Again, we're not dividing or multiplying by negatives here. We subtracted 20. That's okay. That's okay. It's like adding a negative. That's okay. It's when we start multiplying, dividing, we got to watch our negatives. All right? That's when we start doing those things. By the way, let's go ahead and find this little point somewhere. How about it somewhere to the left here, the middle? There's negative 25, we'll say. This time it's got an equals to, so we are going to fill that circle in right off the bat. It's going to fill in. And then, dear friends, we are going to shade. It's less than. I'm going to take it to the left. So there we go. And ta-da. Now, obviously, if you put a negative 25 in there, you're going to get negative 5 and negative 5, which makes the equal. So that's why the closed circle is awesome. Okay, it works great. Now, let's go a little bit to the left here. How about a negative 26 going in there, all right? If I take a negative 26 and add 20 to that, you get negative 6. And folks, negative 6 is less than negative 5, so our check is good. All you need to do is do one value that's in the shaded area to the left of wherever you're going, or if it were to the right, okay? That's all it takes to check. 1 point, 1 point. And, you know, if it works for one, I guarantee you pick any others in that ziggy-zaggy shaded region, you will see it works. See it works. If one works, the other will work also, all right? So let's take a look at a multiplication moment here, all right? It says this is 4y greater than or equal to negative 12. Now, some of you are going like, oh, okay, we got a negative 12. We're going to have to worry about this, right? Remember what I said? It's when you divide or multiply by a negative. Not into a negative, but by a negative that you got to worry. This says 4y, so we're not going to worry. We're going to divide by 4 both ways. And notice what happens is we keep, basically our signs stay the same, and our inequality does not shift. So the 4's go away. We got y. It's still going to be greater than or equal to this negative 3. That's the deal. When we divide by a positive number, inequality does not shift. All right? What it does do down here on the graph, well, let's find negative 3. Put it somewhere there. It is a closed circle. That's fine. And according to this, we're shading to the right. So let's go greater than. Let's go greater than. A little darker than that because it keeps going, it keeps going. Pick a point. We've solved, we've graphed, let's check. So pick a point. Something greater than negative 3. How about negative 2? All right, now negative 4 is not greater than, folks. Watch out. When you pick your numbers, make sure they're to the right here, okay? So let's go with negative 2. If I say 4 times negative 2, boom, 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 gives you negative 8. And negative 8 is greater than negative 12. So our check works. Our checking works on that one, all right? So they're easy, aren't they? They are so easy, so easy. Now what we got to watch out for, you guessed it, Ernie's going to throw a negative at you sooner or later that does need to worry, all right? Yeah, this is one. Here's the one. We are with a negative 4. Notice, how do you determine an inequality when things are going to shift? It's when there's a negative number next to the variable you're trying to get by itself, hooked in by multiplication or division. All right, so let's take a look at this one. We're going to divide. We're going to divide by negative 4, both sides. You got it? Y'all out there? Now, remember what I said. All of a sudden, what was negative 4y has gone to positive y. All right, so we've changed signs. And you know, we've changed signs over here also. That's why we have to worry about the shift, okay? Because signs are changing. Signs are changing. Signs stay the same, or the differences stay the same if you're adding or subtracting. We don't worry. It's when we have to do this sign change by negatives dividing into a positive or negative dividing into a negative. That's where we're worried. So say what? Everybody got it out there? What are we going to do with this? We're not going to have greater than anymore. We got our sign changed. That's good. That's half the battle. Let's go and make a less than happen there, because that completes it. That completes what we're looking at. Now, it is an open circle. Let's find -4 somewhere in our little picture here. There we go. And we're going to open circle there. All right, we're going to open circle it. And according to this, it says we're going less than. We're going to less than. So here we go. It's going to go right this way. And let's see. We can get that zigging and zagging there a little bit. There we go. That's the deal. Here is where we're going to look back and check. Pick -5. -5 is to the left of -4. Let's go with that. We don't use -4 because that'll give us an equals. All right. Let's go with the -5. So we put a -5 in here. That's going to give you +20. And dear friends, guess what? 20 is greater than 16. Go back to where we started. That's the case. That's the case. So it does check. And if you use the numbers to the right here, it wouldn't check out. All right. So if you shade the wrong direction, that's why you check. Pick one of those numbers in your shaded region there, and bang, substitute it back in and see what happens. And you'll be happy, especially if you do it right. Right. All right, let's take a look at one. We've been doing, this is one with it says z over -6. Let me write that. Sometimes it looks a little bit better when we do this than -3. And this is basically z divided by -6 less than or equal to -3. So here again, we've got this -6. We need to remove it. So we're going to multiply both sides by the -6. Put a 1 over those for those that likes to see that. What happens, our -6 cancel, but all of a sudden what was a negative over here has become positive. So we got a z, and we got an 18 going over here, which is positive. And guess what? We need to change the middle. We need to change our inequality. It is now going to greater than or equal to 18. Find 18 somewhere here, fill in the circle, close it up, shade to the right. And we'll make that a little darker. And let's make sure that our answers are good. All right, let's make sure our answers are good. How about it? Let's put in the number of something that divides evenly into 6. But 24. We use +24. If I put a +24 over here and divide it by -6, I get -4. And folks, -4 is less than -3. Good answer. Ding, 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 ding. All right. Now, if I put in 18 by itself, I get -3 and -3. The equals holds. So that's why we've got the filled in circle there. All right. That's what we're kicking on that. So there's your story. My goodness, we could have Facebook also there. Don't forget those things that you can check us out on. Even though we are not live on the air today, you can certainly do Facebook with us. Now, I've got one more little going here. Getting close to the end of that show. We got -7p greater than 0. Some of us get all freaked out with 0. All right? And I want us to take care of this. We are going to get p by itself. So we are going to divide by -7. And we're going to divide this side by -7. Remember, we've got to divide both sides, all right? And according to this, we're going to have p, and dear friends, that's not -7. That's 0. That is 0. But what just happened? What just happened? We divided by a negative number. Now you say, well, Ernie, 0 is not positive or negative. Exactly. But the rule still holds. If I divide any number, whether it's 0, 14, whatever, if I divide it by that -7, both sides, that inequality has to shift. So we're going to be looking at values that look like they are negative here for the answer. All right, let's check and see how that works. Find your 0. Usually most of us like to put it right there in the middle of the number line. Open it up. It's an open circle, right? Open circle here. Which way we shade, my friends? We shifted. We shade to the left. So let's do it. Pull it out there and go to the left. To the left, to the left. Yeah. There it is. Zigging and zagging a little bit on there. And let's test something here. Pick a number, a negative number. If I put a negative number in for p, -7 times -1, it goes positive, right? Everybody got that? +7. 7 is greater than 0. That checks. That checks. So again, very, very critical. You watch for that. Even if you've got a 0, numbers or whatever, there you have it, all right? So let's see. Let's try one more for practice here. Let's take one more for practice here. Ooh, this one got a little switcheroo on it. How about it? Let's see what's happening here. We got 24 and less than or equal to negative 6y. Now there's still a negative y, 6 here going. So we're going to do the same game. We're going to divide by that negative 6. And here's where you got to be careful, my friends, when you see a problem that looks like this. Kind of funky, isn't it? You're going to have y. You're going to shift, which is going to make this less than go to greater than or equal to. And over here we're going to have negative 4. Now, real quick, I like to make my y happen on the other side. So let's switch it over. Negative 4. Negative 4 is your point. Take it out. Go shade to the left. Life is good. And you know what? We're out of time. We'll be live again Monday. Give us a call then. Check us out then. Thanks for tuning in today. See you Monday.